This is DCP pipeline. Watch the brain come online. It observes the stream and on its own decides to install a validation gate, $V. No instruction, no config change. The AI made that call. Then it goes further. That diamond, the anomaly, gets routed to a separate pipeline. Error handling, fraud detection, a quarantine zone? That's for the AI to decide. Pipeline is a stream processing system where the data never waits, not for validation, not for routing, and not for AI. The stream moves, everything else works around it. This is a DCP packet, raw, positional. No field names, you don't know what it means, and that's intentional. Why no field names? Stripping field names from every packet eliminates redundant overhead at scale. When millions of packets flow per second, every byte matters. Positional encoding keeps packets minimal. No schema embedded in the data itself. Structure is the only contract the pipeline needs. Meaning is resolved only at the edges, never midstream. The semantic shadow. The meaning lives separately in the schema. DCP calls this the semantic shadow. It gives meaning to the data packet without embedding it inside. The diagram shows how the schema and data aligns. Each positional slot in the data maps directly to a named field in the shadow. The pipeline itself doesn't need it. Data flows as pure structure. The shadow is only summoned at the edges when a human or a system needs to read. Traditional systems put AI in the loop. Every packet waits for inference. Every decision adds latency. The stream is held hostage to intelligence. DCP inverts this. The pipeline makes fast, deterministic decisions. The AI watches from the outside and changes the rules when needed. The pipeline never waits for AI, not even for a millisecond. The AI watches statistics from outside the stream, no interference with packet flow. It reasons on its own schedule, for example, every 2 seconds, not every packet. When it decides, it updates routing tables, adjusts validation constraints, or approves a quarantine. The change lands on the next packet. 3 layers of judgment. To stress test this design, we're using Minecraft, high-frequency game events arriving as a continuous stream. The pipeline has to keep up, detect anomalies, and adapt, all without stopping. The gate, controlled by the brain AI. Not a fixed validator, a dynamic control point, updated in real time based on what the brain decides. Domain filter, stateful rules. Applies domain-specific rules the schema alone cannot express. Game logic, business rules, physical constraints, anything requiring context across multiple packets. Preprocessor, structural integrity. Drop corrupt records, quarantine uncertain ones, pass only clean data. The first line of defense. So here is what we tested with Minecraft. Scenario A, normal traffic player. Move events, combat events, block placements, all arriving within expected ranges. Pass rate. The brain has nothing to act on. The pipeline runs silent. Median latency. From ingest to gate, preprocessing, domain filtering, and validation all included. Brain cycle. Thousands of packets flow through before a single brain decision is made. The preprocessor passes everything clean. The domain filter finds nothing unusual. The gate confirms validity. The stream flows without a single intervention. Scenario B, combat cluster. Multiple high-damage events arrive in a short window. The domain filter detects abnormal damage values. These are not structural errors, they are game rule violations. Each one is counted as a failure in the statistics collector. The pass rate drops. At this point, a traditional system would pause. It would wait for AI. It would block the stream. DCP doesn't. The stream was already moving. A statistical monitor, the bot, detects the pattern and signals the brain. 2 seconds later, the brain makes its decision. route combat events to the PvP pipeline. The routing update takes effect on the next packet. No restart, no interruption. The decision arrived late. The stream never cared. It was already moving. Scenario C, Schema Evolution. An unknown field arrives. A new version of the game client is sending an extra field the current schema doesn't recognize. Preprocessor catches. It not flagged as corruption, identified as a schema boundary event. The record goes into quarantine while everything else continues. Brain receives notification. The brain receives the quarantine notification and identifies the reason, unknown field from a newer client version. Brain approves. It signals that this field is expected under a newer schema version, schema evolution, handled without breaking the pipeline. The pipeline didn't break. It held the record, surfaced it for judgment, and continued processing everything else without interruption. Intelligence outside, stream inside, the pipeline never stops. We have seen 3 scenarios using Minecraft, and one principle is what matters. A stream should never wait for intelligence. Because intelligence is slow, inference takes time, and streams don't. DCP is built on that constraint. The pipeline runs fast, continuous, deterministic. The intelligence runs outside, watching, learning. They don't wait for each other. And when the AI finally acts, the stream never noticed. It was already moving.